Welcome to Math with Mr. J. In this video, I'm going to cover how to find slope. We will go through two sections: how to find slope from a graph by counting units, and then how to find slope from 2 points. We will start with counting units. Now remember, slope measures the steepness of a line, so how much a line goes up or down as it moves from left to right. Let's jump into number 1, where we need to find the slope of the line graphed on the coordinate plane. Now looking at the line, notice that the line is moving upward as it's moving from left to right. This is what we call a positive slope. As far as finding the slope, slope equals the rise over the run. So the vertical change over the horizontal change. Basically, we're looking at how fast is this line moving upward as it moves from left to right. When finding slope, we use any 2 points on the line. It doesn't matter which two. We will get the same slope. So let's use this point right here and this point right here. We need to figure out how far up and how far over we go between these 2 points. We're going to move from the left point to the right point. We go up 1 unit, 2 units, 3 units to align with the other point. That's our rise, the vertical change. Then we go over 1 unit, 2 units, 3 units, 4 units to get to the other point. So that's our run, the horizontal change. So slope equals, and I'm using m for slope here. We can use m to represent slope. So slope equals rise over run. And now we can plug in our rise and run. The rise is 3. The run is 4. And this is our slope. 3 over 4, 3/4. The slope tells us that this line goes up 3 units for every 4 units it goes to the right. Now before moving on to number 2, I do want to go over how any other 2 points will work as well. So if we pick this point right here and this point right here, let's see what the slope will be. Well, we go up 1 unit, 2 units, 3 units. So our rise here is 3. And then we go over 1 unit, 2 units, 3 units, 4 units. So our run is 4. We end up with the same slope. But what if we pick this point right here and this point right here? Well, the rise is 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units to align with that point. So the rise is 6. And then our run, well, 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units. So our run is 8. So slope equals, our rise was 6 and our run was 8. So we end up with a slope of 6 over 8, 6/8. So did we get a different slope? The answer is actually no. This is the same slope because when it comes to slope, we want to look to simplify any fractions, and 6/8 can be simplified. 6/8 is actually equivalent to 3/4. As far as simplifying, 6 and 8 have a common factor of 2 that we can divide by. 6 divided by 2 is 3, and 8 divided by 2 is 4. So we get that slope of 3/4. Let's try some more examples and move on to number 2. Taking a look at number 2, notice that this line is moving downward from left to right. This is what we call a negative slope. So let's find the slope. Again, slope equals rise over run. So let's find the rise and run here. So we need to pick any 2 points. Let's pick this point and this point. Let's start with the rise, the vertical change. So looking from the left point to the right point here, we need to go down from the left point to align with the right point. We go down 1 unit, 2 units, and since we went down, our rise is negative. This is -2. That's our vertical change. Now for the run, we go over 1 unit, 2 units, 3 units, 4 units, 5 units in order to get to the other point. So our run, the horizontal change, is 5. And that's a positive 5 since we moved to the right. Now we can plug in our rise and run here. Our rise is -2 and our run is 5. This is our slope. And this fraction is in simplest form, so we are done. -2 over 5, -2/5. The slope tells us that this line goes down 2 units for every 5 units it goes to the right. And just to check, let's use this point and this point to see if we get the same thing. So our vertical change here is 1 unit, 2 units down, so -2 here. And then our run, the horizontal change, we go 1 unit, 2 units, 3 units, 4 units, and 5 units. So our run is 5. Let's move on to number 3. Now let's take a look at number 3, where we have another example of a negative slope. This line is moving downward from left to right. So let's find the slope. So slope equals rise over run. Let's write this out again in order to get this down. And now let's find the rise and the run. We'll use this point right here and this point right here. Let's start with the rise, and we're going to go down in order to align with the other point. So starting here, we go down 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. So our rise, the vertical change, is -6 since we went down. Now we need our run, the horizontal change, and we only go over 1 unit here, and we went to the right, so this is a +1. So our run is 1. So let's write our slope here. So our slope equals the rise, -6, and the run, 1. So our slope, -6 over 1. That slope tells us that this line goes down 6 units for every 1 unit it goes to the right. Now, something to keep in mind here, since the denominator is 1, we can also write this slope as just -6. Either of these will work and mean the same thing. Keeping the fractional form makes the rise and run a little more clear, but we will also see slope written as just an integer. So if you ever see the slope written as just an integer, so no fraction, the run is 1. Lastly, let's move on to number 4. Taking a look at number 4, we have a line with a positive slope. It's moving upward as it's moving from left to right. Let's find the slope. So slope equals rise over run. So let's find the rise and the run here. So we'll use the 2 points we are given, this point right here and this point right here. So we'll go from the left point to the right point. Let's start with the rise. We go up 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units, 9 units, 10 units. So our rise, the vertical change, is 10, and that's a +10. We went up. Now for the run, we go over 1 unit, 2 units, 3 units, and that's a positive 3 since we went to the right. So our run, the horizontal change, is 3. So our slope here is 10 over 3, 10 thirds. That tells us that this line goes up 10 units for every 3 units it goes to the right. So there's how to find slope from a graph by counting units. Let's move on to finding slope from 2 points. Here's our section on finding slope from 2 points. In our previous section, we counted units. Here, we're going to use the coordinates of the points to find slope. We use this formula right here. Slope equals y2 minus y1 over x2 minus x1. y2 minus y1 gives us our vertical change, and x2 minus x1 gives us our horizontal change. So this is still rise over run here. We're just using the coordinates of the 2 points to find the rise and run. Now you'll notice our points are at 3, 1 and 5, 8. We need to pick our first point and our second point. Now, does it matter which is which? No, we will get the same slope either way, which I will show later. I typically like working from left to right, so the left point to the right point, since we are looking for the slope of the line as it moves from left to right. So let's use 3, 1 as our first point, so x1 and y1, and then 5, 8 is going to be our second point, so x2 and y2. Let's label these now. So for 3, 1, 3 is our x coordinate, so let's label that as x1, and then 1 is our y coordinate, so let's label that y1. Now for 5, 8. 5 is going to be x2, and 8 is going to be y2. Now all we need to do is plug these in to our formula, and I'm going to rewrite our formula in order to help us get this down. So slope equals, and I'm using m for slope here, y2 minus y1 over x2 minus x1. So plugging these in, we have slope equals, well, y2 is 8 minus y1 is 1. So we have 8 minus 1 there. And then x2 is 5 and x1 is 3. So we have 5 minus 3. 8 minus 1 gives us 7. And then 5 minus 3 gives us 2. And that's our slope, 7 over 2, 7 halves. 7 is our rise, and 2 is our run. That formula gave us the rise and the run, so the vertical change and the horizontal change. Now you may also hear the rise called the change in y, and the run called the change in x. Now we did not need the line on the graph to find the slope here, because we were just able to use the points, the coordinates. But I wanted to include it to give us a visual of the slope and show that counting units gives us the same slope. So taking a look at the line, let's work from left to right, so this point to this point, and find the rise and the run. Let's start with the rise, so 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units in order to align with the other point. So the rise is 7. And then as far as the run, we need to go over 1 unit, 2 units. So the run is 2. So we get the same slope that way as well. So rise of 7, run of 2. Now before moving on, I want to show real quick that switching the first and second point will still give us the same slope. And what I mean by that is using 5, 8 as x1 and y1, and then 3, 1 as x2 and y2. So rewriting these, we have 3, 1 and 5, 8. So we're going to switch here. 3 is going to be x2 and 1 is going to be y2. 5 is going to be x1 and 8 is going to be y1. So slope equals y2 minus y1 over x2 minus x1. Now let's plug in. Y2 is 1 minus y1 is 8 over x2 is 3 minus x1 is 5. 1 minus 8 gives us negative 7. And then 3 minus 5 gives us negative 2. So we get negative 7 over negative 2. And if we look at the graph and start at the right point, 5, 8, we go down 7 and to the left 2. That gets us to the other point, 3, 1. So the rise is negative 7 and the run is negative 2 when we go from the right point to the left point, which we have a negative over a negative. Negative in both the numerator and denominator. A negative over a negative, which is a negative divided by a negative, gives us a positive. So this can be written as a positive 7 over 2. And that makes sense. This should be positive. Think about it. We can see that this line has a positive slope. It's moving upward as it moves from left to right. So we can actually write this as a positive 7 over 2, a positive 7 halves. And you can see that we get the same slope. Again, a negative over a negative results in a positive slope. So we can see that we get the same slope either way there. Something we can't do is mix and match. For example, let me come up here and find some room. So we'll say this is 3, 1, and then 5, 8. We can't make 3 x1 and then 1 y2 and then 5 x2 and then 8 y1. So we can't mix and match. That's not going to give us the correct slope. Let's move on to our next examples. Taking a look at numbers 2 and 3, we are given the coordinates of 2 points that a line passes through. We need to find the slope of each line using the given points. Let's jump into number 2 where we have negative 8, 6 and 0, 2. So slope equals y2 minus y1 over x2 minus x1. Let's make negative 8 x1 and 6 y1. Then 0 x2 and 2 y2. Now we can plug in. y2 is 2 minus y1 is 6 over x2 is 0 minus x1, which is negative 8. And I'm putting negative 8 in parentheses there just so it's clear we are working with a negative and it doesn't get lost next to the subtraction sign. Now let's subtract. 2 minus 6 gives us negative 4, and then we have 0 minus negative 8. Now, whenever we have subtraction problems involving integers and we have positives and negatives, it can be helpful to add the opposite. And this is one of those problems where this can be helpful. So we add the opposite. The opposite of negative 8 is positive 8. So we have 0 plus 8, which is 8. And that's our slope. Negative 4 over 8, negative 4 eighths. Now this fraction can be simplified, and when it comes to slope, we want to look to simplify if possible. The greatest common factor between negative 4 and 8 is 4, so let's divide both -4 and 8 by 4. -4 divided by 4 gives us -1, and 8 divided by 4 gives us 2. So our final simplified slope is -1/2. Let's move on to number 3, where we have -7/4 and -1/9. So slope equals y2 minus y1 over x2 minus x1. Let's make -7 x1 and 4 y1, and then -1 x2 and 9 y2. So let's plug those in. y2 is 9 minus y1 is 4 over x2 is -1 minus x1 is -7. Now we can subtract. 9 minus 4 gives us 5, and then -1 minus -7. Let's add the opposite here. So add the opposite. -1 plus 7 gives us a positive 6. So our slope here, 5 over 6, 5/6, which this is in simplest form. So we are done. So there you have it. There's how to find the slope of a line. I hope that helped. Thanks so much for watching. Until next time, peace.